I'm not going to have you turn this in right now. The rewrite on this back page, right? You had to rewrite like number 11 and in 13 you had to rewrite both of them. When we rewrote both of the equations in 13, first, if you did not do this, please in your workbook do this one with me right now. If we were getting that negative 3y by itself, you would have had negative 3y equals negative 18x plus 21. If I have that, Jaden, what do I need to do to rewrite it in y equals form?
Me?
Jaden over here.
You take everything times negative 3 on the other side.
Not times negative 3.
Divide that.
We got to divide everything by negative 3. So that my new equation for this first one in 13 is y equals negative divided by negative gives us 6x. 21 divided by negative 3 gives us a minus 7. This next equation, Gunnar, that's like a negative 1 in front of y. What do I need to do to get it to be just y? Divide everything by negative 1. And now I get y equals 6x minus 7. And so when I see them both written this way, I can graph them, right? But what I already know is if they have the same slope and the same y-intercept, what's going to happen when we graph it? It's going to be the same line. And the same lines have what for a solution? Infinitely many. Do you still need to graph it? Yes. Okay? But you only are graphing one line, right? Because it's one line on top of the other one. Okay? Are there any others, when you use the graphing calculator, you're using the y equals button to put in an equation? So if you would please right now take your computers out and go to, and you're just going to type in Desmos.com. Okay? So just type that in. As I write my first equation from my notes on page 7, I am going to write y equals, and you can use your keyboard. You can either click on it or just hit the y. Use your equal sign, and we are putting in 2x. Use the x button, right? And then you're putting plus 3. Okay, everyone? Yep, I did 2, so we want 3. Now, please draw this picture in your notes. So when I look at your notes, okay, because that's where we are taking these from, you are going to go down here and you are going to draw
what page in our notes?
Page 7. And so we draw that exact same one, and the key thing I'm looking for is you need to make sure you get the right y-intercepts. So here we had in that first one the y-intercept of 3, y-intercept of negative 4, right? So once I have those two, I am now looking for what is our solution. And our solution should be
No solution.
no solution, right?
Okay.
In that second equation, we want to rewrite them first in slope-intercept form. So when you take a look at the second equation, if I was going to rewrite that, Traylon, that first equation of x plus y equals 5, how do I get the y by itself? Minus x. So I'm going to have y equals minus x plus 5. Second equation. What might I be doing, Timothy, to get my y by itself?
Does it have to be right on?
This needs to be not exactly, but pretty close, because you're using the graphing calculator. So you're just going to kind of make sure that you can kind of see the 2 points, and then that you can kind of tell that it's like 2 over 1. It doesn't have to be exact. What would you say you're going to do here? We're going to add x to both sides, and we now have this negative y equals negative x plus 1, but we have to divide everything by negative 1. Now, when you do your homework tonight, you always have to get it in this form. So we would have had y equaled x minus 1. So you are now going to go back to your graphing calculator, and I want you to notice that if you click on this blue part out in front, so just click on where you have the equations stay there, but they're not graphed anymore, right? So by doing this, you can put in a bunch of equations. So we can go to number 3 and type in y equals negative x plus 5. And now we can go to the next equation. And that next equation, what if I put it in the graphing calculator? Now, anytime you use an actual graphing calculator, you always have to have it in the y equals form. But on this one, if we typed in x minus y, does it work? X minus y equals 1. So what if I would have typed in the new equation that we got of y equals x minus 1? It's exactly the same, right?
Wow.
These two are the same, right? So what's really nice about the Desmos calculator is you do not have to have it in slope-intercept form. You do when you do your homework tonight. So what I need for you to draw on that second graph is we are going to draw these two lines. One has a y-intercept of 5, right? One has a y-intercept of negative 1. So even if you left the equation in the form of x minus y equals 1, you still have to make sure you get the right y-intercept on your graph. So when I look at your graph, as I look at this one, I am going to make sure I have a y-intercept at negative 1 and a y-intercept at 5. Okay? So that my solution was the ordered pair 3, 2. And 3 plus 2 equals 5, and 3 minus 2 equals 1. So it checks in both equations if I'm looking at that. Okay? So please put in this last one, and as we put that in, we are going to put that equation in, and as you write that one in, we're going to write it exactly as it's written in your workbook. So we're going to have x plus y equals negative 1. So looking at this equation, can you rewrite it in slope-intercept form? What should the new equation be in slope-intercept form? Y equals, what's our y-intercept? Negative 1. And the slope is also negative 1. And if you look at this and we tell it we want a table. Table is when you actually put in the x and y values. You don't get to see a table of these values. So when you look at this, do not think you can't put it in as a table. So just so if you were looking at that. So now make sure that you rewrite this equation right behind it. So we just said that this one was going to be y equals, right? The first one here is now going to be y equals, this first one was y equals negative x minus 1. If you were dividing this one to get y by itself, what would I need to do, Chase?
Divide everything by 2.
Divide everything by, careful, negative 2? Okay. So, but we're going to put it in exactly as it's written. So when you go back to the Desmos calculator, you're going to type it in as 2x for your second equation. So 2x plus 2 equals negative 2y. It was? It's exactly the same, right? So I could at this point, right, go back to this equation, and if I am graphing them, what do I know my solution is going to be? Infinitely many, okay? So the equations don't look the same, but when you rewrite them, they are the same. Now, this one says solve on that next page, solve the system using the graphing calculator. And what I want you to do is when you put in the equations, as you do that on the graphing calculator, on a lot of yours I saw the no solution, which is good. And I'm going to move this in just a minute, but I just wanted to show you when you use a graphing calculator, what you always have to do is, so a lot of times this is the second how you get to like that home screen, which is where you put your numbers in if you're using. And if you're using one of our graphing calculators, you put in the y equals. And we said that this first equation, when we rewrite it, it was supposed to be y equals, we said it was going to be negative. And so the negative on the graphing calculators, you have to use like -2. And then we use this X button. And then we would have had +1. And this is doing this problem right here, problem 1. Okay, so I would put that one in. And then I go to my second equation. And this one we said was going to be y equals x. So you don't put the y equals, you just type the x. And then we said it was going to be x if we were looking at our equation. We said this one was y equaled x plus -4. This one was y equaled -2x plus 1. So those are the two equations I'm putting in. And I just want to show you how you're going to get the same answer using the graphing calculator. So -4. And then on the graphing calculator, there's different ways you can graph it. And we always want to have the zoom, and it is usually zoom, and it is our standard one, which is 6. And so that is like a 10 by 10 grid. And the nice thing about the graphing calculators is that I graph both of those, and I can see that same point of intersection that we had right here. But the nice thing about graphing calculators is that I can tell it to find that solution for me. So there's a couple ways of doing that. I can use this trace button, and notice that this trace button is I can move on the line. So what's happening is I'm moving on my line. I got x being 9. So if I'm looking at this is x is 9, y is 280, right? So when we look at ours, there's just different ways of finding those solutions. When I looked at yours, did you guys get that last solution on your graphing calculator? Yep. Okay. So let's go to the last problem in your notes. The last problem in your notes says this, has this question. As we look at this, it says, when Ethan and her friends went to an amusement park, they offered 2 admissions. Option A, buy an admission ticket for $5 and pay 25 cents a ride, or buy an admission ticket for $2.75 a ride. It says, which option is a better deal? When is each option the best choice? Write a system of equations, use your graphing calculator to solve. So we're going to start. Jack, I'm going to go y, and I'm going to call it sub A. So on your paper, everyone in your notes, we're not doing our graphing calculator yet. So y sub A, Jack, what is my rate of change for option A?
25 cents.
25 cents. So I'm at 0.25, and then Jack Rose, what? So 0.25x, and I'm adding what was my starting point? Plus 5. So now I'm going to have y sub b, and that just means it's choice b. And Logan, if I'm looking at choice b, how much was my rate of change per ride? 0.75x. And then Emily, I should have plus, how much was my entrance fee or beginning? Plus 2. So put these, what's that? Oh, 0.75. Thank you. So please put these two in your graphing calculator, right? So you're going to type those two in and find your solution, and then we want to answer those 2 questions. So our equations, again, you're going to put the y equals. What's nice when you're using your keyboard, the 0.25x. And then we had plus 5. And you're going to put your second equation in. They both have positive slopes. Y equals our 0.75x. What's that? Click on out in front so that it's on, right? Make sure you have it on. So if we are looking at these two, one of the things, some of you like to zoom in, or if you're zooming out, and then the home button is kind of the home screen, right? So in this case, I might want to zoom out, or hit that zoom, that minus zoom, zooming out, so that I can see this point. So when is it a better buy when is it better to have the blue line? Up to what point? Up to how many rides? Up to 6 rides, right? So what I want you to do in your notes, if we are looking at this, so the question says, if we were going to look at that graph, right, we want to have a point of intersection, right? Where is that point of intersection going to be? At 6 and what? 6 and, yeah. So I'm going to do my 2 lines kind of like this and put this point, 6 comma 6.5. So the question is, right, this is our lower one. This is the equation for the top one. So it says, which option is a better deal? Well, it depends, right? Depends how many rides you're going on. Option B is a better deal if you're only going to go on less than 6 rides, right? So if we are looking at this, which option is a better deal? B is better if you do what? If you only go on 1 to 5 rides, right? It's equal at 6 rides, doesn't matter, right? Which option you choose. And A is better if what? You go on more than, and we want to say more than 6 rides, right? 7, 8, 9 rides, right? Because at 6 rides, they were exactly the same, okay? So yesterday you had your graph paper. Tonight you are doing this problem. So I gave you G3 graph paper to do this on. If you